Okay, so now we're going to look at the surface area and volume of pyramids and cones. Okay, so once again, we talked about how to put the flip books together, and you're going to put your title page on front, and then each page getting longer and longer until the longest one is in the back. Okay, so a pyramid is also a polyhedron. Remember, we talked about what polyhedrons were in the previous video, which is a 3D shape with no curves. So a pyramid is a polyhedron that has one polygon base. So polygon means a shape that is not curved, straight edges only. And it has a vertex, okay? The lateral faces are always triangles when it's a pyramid. The lateral faces are always triangles with a common vertex. So like what we have here is we have a pyramid. Here's our base right here. Is the blue shape. It has 3 lateral faces and they all meet in a common vertex, D. And so just to show you like another example, we could have, let's say like a pentagonal prism where the base was a pentagon. And, sorry, that's terrible. All the sides meet at a common vertex up at the top, and it makes sides that are shaped like triangles. Okay. So the slant height is the height of a lateral face. Okay, this one's always hard for students to get. It's the difference between the slant height and the height. All right, so let's talk about the height real quick also. We'll come back to the base edge. The altitude or height is the perpendicular distance. So a height is always at a right angle. So let's highlight, let's color code here. The altitude or height is a perpendicular distance between the base and the vertex. So right here from the vertex D, straight down to the base at a right angle, that is your height. Call that H. Now, your slant height is the height of a lateral face. So like the distance, the height of this triangle right here. And it's L is the letter we use for slant height. So, for example, if you took this triangular pyramid, let me try to draw that. Okay, so this is ABC. That's the base you're seeing in the pyramid they gave us. And if we draw the net, which is like the figure laid out, so like if you cut it all apart, so the faces laid out. So the faces are all triangles. And so the slant height is the distance or the height of the face. So like right here, that's the slant height. And so it literally slants. Okay, a base edge is the segment connecting the vertices on the base. So just like a base edge of a prism. So let's just see here, a base edge would be like the edge of a base. No big deal. Okay, so that's our vocabulary. So remember, a pyramid is a polyhedron, no curves. What we call it, if it has curves like a circle base, that would be a cone. Okay, so we're going to do volume first. And just like the previous one, the volume is honestly the easiest one. So the formula for volume is 1/3 capital B H. And once again, the uppercase B is the area of the base. And the lowercase h is the height, which is also known as the altitude. And remember, it's the distance perpendicular to the base from the vertex down to the base. Okay, so if we go ahead and do this, we have our first sample here. If we look at this, the base is a hexagon. And is a regular hexagon. So once again, for our area of the base, we're going to use our formula for the area of regular polygons like we've learned previously, the 1/2 apothem times perimeter. Okay, so 1/2, the apothem is 2 square root 3. We see that right here. This is the apothem right here. Okay, so that's the apothem. And then the perimeter of the base. Keep in mind the perimeter of the base, each side is 4, and there are 6 sides. So 4 times 6 is 24. Okay. So if we have that, we can once again go ahead and type that in a calculator, and we get 24 square root 3. If that looks familiar, it's because it has the same base as one of our prisms did on the previous flip book. Okay, now the height of the figure is 6. Okay, this distance right here goes from the vertex down at a right angle to the base, and that's the height. So to find our volume, it's 1/3 the area of the base, that's 24 square root 3, times the height. And so I use it with the square root of 3 if possible, because why round if I don't have to until the very end. Okay, so now, find my calculator here. We're going to type it in our calculator. So we have, let's see here, 1/3 of 24 square root 3 times 6. Okay, I got roughly 83.14, and we are in centimeters, and this is cubed because it's a volume. Okay, so now think about your cylinder. Cannot spell tonight, guys. Okay, so your area at the base is a circle, so it's pi r squared. They say our radius is 3, so there's our r. So that is 3 squared is 9. So I'm just going to call it 9 pi for now, so I don't have to round until the very end. The height of the cylinder is 7 centimeters. So the volume equals 1/3 the area of the base times the height. Okay, so once again, typing that in our calculator. So we end up with, let's see here, 65.97, and we are in centimeters, and it's cubed because it's volume. Now, one thing to think about the cylinder is, since it is always 1/3 the area of the base on a cylinder is always a circle, and the area formula is always pi r squared. So you can put that instead of the area of the base, and then times the height. So that's the same thing, it's just that instead of area of the base, we're putting pi r squared. So we can remember a separate formula for so sorry, that's on a cylinder. It's late, guys, I apologize. The area for a cone, oh my gosh, volume of a cone. But we also, personally, I don't remember a separate formula. I just stick with the formula, volume equals 1/3 base times height, area of the base times the height. And that works for pyramids and cones. And so I would rather memorize one formula than a whole bunch. Okay. So let's talk about lateral area and surface area. I'd like to do surface area first. So the surface area of a pyramid or a cone is the area at the base, so it's not 2b, it's just b because there's only one base, plus 1/2 the perimeter of the base times the slant height. Okay, so remember, capital B is area of the base, capital P is perimeter of the base, and the lowercase l, that's kind of cursive, is the slant height. Okay, so down here we have a couple different types of pyramids. And so if we look at that, then we have our base, in this case, is a triangle, so it's a triangular pyramid. And so keep in mind, this is a right triangle. I'm just going to draw this separately right here. This is 3, this is 4. It shows a right angle right here. So this can be my base of my triangle, lowercase b, and this is my height of my triangle. So the area of the base, the area of a triangle, is 1/2 base times height. So I end up with 6. Now, my perimeter of the base, that's the perimeter around. Okay, the perimeter of the base is 3 plus 4 plus I need this missing side. So how I'm going to find that, since this is a right triangle, is I'm going to sit here to find this side, and I'm going to do 3 squared plus 4 squared equals c squared. And I find out, let's see, that this is 25. And then my square root, this missing side is 5. So the perimeter is 3 plus 4 plus 5, which is going to be, kind of having a brain fart here, 4, 5, 6, 7, 12. Okay, and then the slant height they told us is 7. So they said it right here, but it is the distance that's like along the side, it's the height of the side. Okay, so remember, our surface area is base, area of the base, plus 1/2 perimeter of the base times slant height. So surface area equals area of the base plus 1/2 perimeter of the base times slant height. So area of the base is 6 plus 1/2, perimeter is 12, slant height 7. All right, so we can feel free to plug that into a calculator if we would like, and we're going to end up with 48, and we're in centimeters, and when it's the surface area, we're squared. Okay, so let's look at this pyramid. It has a square for a base, so it's called a square pyramid. So this one's pretty easy because we don't have to do so much math to find the missing pieces. So right here we have our area of our base, a square is just 12 times 12. That's 144. Our perimeter of the base, there's 4 sides and they're all 12 centimeters long, so that's 48. And they gave us our slant height, which is 15. So we're just going to plug into our formula real quick. So our surface area equals our area of the base plus half the perimeter times the slant height, which is 15. And if we type that in a calculator, we get 504 centimeters squared. So real quick, let's talk about this. If we had a cone, it's going to be the same formula, but let's just think about what we'd use. Our area of the base of a cone is a circle base, so it'd be pi r squared. And then we'd have half. Our perimeter of a cone is going to be the circumference of the circle, so that's 2 pi r. So you have pi r squared. Now if you do half times 2 pi r, that's just pi r, because the half and the 2 make 1, and then there's still the slant height. So that's the surface area of a cone. But like I said before, personally, I just use the surface area of a pyramid for it, because honestly, I just don't need more formulas in my life. The other thing I want to talk about is sometimes, let's take a look just at this pyramid. If we didn't know the slant height was 15, sometimes they will give us the actual height. Like let's say that we knew, I don't know, let's just pretend that was 10. If they give us the actual height, you can find the slant height by making a right triangle and figuring out this is the slant height, and you can know that this was 6 because this is also 6, divides it in half. And you can use Pythagorean theorem to find the slant height. Sometimes we don't know something and we have to use math to find the missing piece. That happens quite a bit. So these are kind of basic problems, but we're going to get more difficult in our homework over the next week.